For most part in this course, we'll be studying mechanisms with 4 links connected in a loop. Now, this might seem awfully simple to keep anyone busy for a complete semester. But believe me, the variation of motion that it offers with just simple changes in pairs or link lengths is simply mind-boggling. So here is the simplest of its kind. 4 links, 1, 2, 3, 4, connected with revolute pairs here, here, here and here, okay, forming what is called as a 4-bar mechanism. And we are going to learn a test that tells if this mechanism will have a link capable of complete rotation. Now, why are we so concerned about having a link that completely rotates? Because such a link can then be connected to an electric motor, or in olden days say a steam engine or a internal combustion engine, and the whole mechanism can then be driven automatically. The condition we are going to study is called Grashoffs criteria. It says if the sum of the shortest and the longest link lengths is less than the sum of the remaining 2 link lengths, then we should have a crank in our 4-bar mechanism. Here is one such mechanism. Let us test it. So the shortest link and the longest link add up to 30 plus 80 equal to 110, and the other 2 links 50 plus 70 add up to 120. So Grashoffs criteria says we should have a crank here. So let's test by actually dragging on one of the links here, the shortest link, and indeed it is capable of complete rotation. It is not even necessary that the shortest and the longest link should be one next to the other as over here. We can as well have them on opposite sides. So for the link lengths satisfy Grashoffs criteria, we will have a crank. Now here we are not getting a crank. Why could that be? Let's see. 35 and 90 add up to 125, while 50 plus 70 is only 120. So Grashoffs criteria is violated. So the mechanism gets locked in this position or that position, and it can't move. So let us change the link lengths. So I will change this to 30 and this to 80 and retest it. And there we go. Now we have a crank again. Here is an interesting question for you. Do you think for Grashoffs criteria to hold good, the smallest link should be free to move like this? Or could the longer link become a crank? You can pause the video now and think about it, because next we are going to fix the smallest link and do this experiment and find out. Okay, so let us zoom to this mechanism here. I'm going to turn on the construction so you can see its bare bones underneath. Then I'm going to release this link so its direction is no more fixed, and we will fix the direction of our smallest link. So it is fixed at this point and this direction is fixed. Let's hide the construction and try to drag on the longest link. And there we go. It still rotates completely. So Grashoffs criteria is independent of which link is fixed.